Right folks, well as promised we've got a Lowe TX40 in a box. So it uses the PT40 chassis, which I like even if you don't, and we've got a timer running. You know what, there's a lot of people who wouldn't start work if they'd only got 20 minutes. This is all part of not having a television and not having distractions. So we get this started in 18 minutes. Who knows, we might even get through the initial tests. Now these are complex to set up because it all stems around setting the delta tune. That is the whole priority thing, which is bonkers, but that's how it is on this set. Same chassis as the Grandstand Hawk, and then you've got the other PT40s which are lesser, the World Sound one and so on. And if there is a worse one in this series, it's the one with no public address feature. You actually got a half decent instruction book with a square kit diagram. And we've got the Lowe coffin mic, we've got the bracket. I remember these being cleared at just $29.99. The duster. So he says it's immaculate. This is Mr. Trucking and Farming. It is. They can be prone to rust. Now they're 40 years old. It's a bit in line with the SMC Oscar, more in line with a CB set aimed at amateur radio enthusiasts rather than a CB radio for CB radio enthusiasts. Lowe Electronics was the Trio dealership at the time at Matlock in Derbyshire, when Trio was the branding used for Kenwood, because Kenwood couldn't use Kenwood owing to the fact that Kenwood chef and other food type items had the same name. So these are self-tapping screws just to annoy everybody. Tell you what, we won't take any more out and we'll do all the tests like that. Plug into our crocodile clip lead. I'd better go and see whether our video has finished processing for the on-the-air test for the Unidem base station. The answer is no, it's at 72%. Right, so we'll go over to picture-in-picture. I'll switch this radio on. 13.8 volts. We'll use the standard Cybernet mic, because that's how these are wired. Come on, it's on 19. Delta tune has a click position for normal. Make sure RF gains at full. Squelch is down. That's PA. I tell you what, whilst we've got it in PA, Testing 1, 2, 3, 4, 5. We're not using it, surely. No, I'm not. I'm an extension speaker. What a wally. Testing 1, 2, 3, 1, 2, 3. Right. So meter lamp's working and PA's working. Going to extension speaker. So you're usually going to find I'm going to start again. You're usually going to find the receivers screwed up because they're difficult to set up. You need the proper service manual. You can't guess it. Got to know the test points. It's very time consuming. Right, it's going to transmit. They never do 4 watts, but that doesn't matter. We're actually doing 3.1. Current consumption 1.025, which is a lot for 3 watts. 1.025 amps. Tells me it's a bit screwed up. 400 milliwatts. Let's have a look. On low power, 240 milliwatts. Can't remember whether these are adjustable or not. Let's see what the deviation is just for giggles on this test set. Wow, 1.5 on this one. The test set's not been on long. We'll do the frequency, but we'll not adjust it till after I come back from a... Oh, it's... Yeah, right, 79097. I mean, it's right. 2779097 is not far off 2779125, which it should be. But you can't just adjust one thing and it all happens. It's all done. It's all set with receive and delta tune, and then you trim transmit. High power. Let's look where the meter is. The meter says it's... I'll just tick it off because it isn't marked. So on receive, and it's not really connected with receive. Transmit and receive aren't necessarily the same frequency, but in case they are, we'll put the same frequency in. So 27791. What was it? 097. I mean, it's clearly not far out as far as that goes. Slight noise on volume control. Right, we'll plug in the SINAD meter. We're probably going to need an earth. Yep. Right, it's not a nice waveform on the oscilloscope, but we're not here to do that at this point. Let's go over to SINAD meter. Oh my goodness. It's deaf. 3 microvolts. .25 microvolts. I don't expect I'll ever do 20. No. So predictably the receiver's been screwed up. It won't have done this on its own, it will be a screwdriver expert. A squelch. Let's put the attenuator up if you can see it be locked between the paperwork and the wiring. So that's on 0, 10, 30, 10. Actually, it opens at maximum squelch 300 microvolts. Right, let's do the opposite. Well, to be honest, considering it's 2.4 microvolts, that surprised me. Switches work, sockets work, meter 100 microvolts on the test set should give us S9. And you know what? It's not far out, it's 300 microvolts. Right, and that works. So we'll get the lids off, we'll get the service manual out, which I was doing a grandstand hawk a few weeks ago, so I think we should have that and not thrown it away because I printed it out A3. I think you have to do the receive first on these. It's the way it is. I'll ask Mary the story behind this because it's immaculate set in a box, and yet it's clearly being farted about with and tweaked down, not up. So these were quite an old-fashioned design at the time. Oh, somebody's put a crystal filter in, that might be the reason. It's play toy time. Yeah, they've stopped the bleed over, haven't they? They've stopped everything. Yep. Oh well, we might as well take the other lid off. What I'm hoping is that they haven't taken out a coil, because it probably could have used a tuned circuit there, and now they've turned it into this crystal filtered thing. Oh, let's get a new set and turn it into a play toy. Yeah. So, well, they certainly would have got rid of the bleed over, wouldn't they? Because they've got rid of most of the receiver as well. So I'm going to have to dig out the service manual to see whether L17 is supposed to have a coil in it or something else or whatever. If I haven't, I'll print another copy. What's the copy off? It's quicker. Right, I'll see you when I've done Mrs. Thingy's shopping. Right, well, I mean, I just can't believe what I'm seeing. So, someone's decided to fit a crystal filter. L17 should be there. So let's look at the circuit. L17. So here's the logic. They've taken out L17 and put a crystal filter in, so we're losing a tuned stage, gaining a crystal filter. But this is the 455 filter, surely. Where's that show? Not quite sure why the filter doesn't show on my layout. We've got L18 and then resistor filter, resistor filter. L18, resistor 50, no filter showing. Okay. Well, this is what we're going to do. Not something I want to do. Now I think in the next period we'll come. We haven't got a scrap PT40 because every single one of them, whatever version, right down to the dead basic PT40, which is this. This is the World Sound PT40 in its basic version. We've got this on the shelf for restoration, and all that's missing is the grommet. It's a complete set. What we're going to do, because I have every confidence, this is on one side because the audio IC is missing. All we have to do to make this back to a full set is to make an aluminium bracket, which is missing, and put a new audio chip in it. That is all that's missing. And what we're going to do is borrow what's shown as T10 in this one, which is the same part. We're going to borrow it out of this set, and I've absolutely, between now and croaking it, I am absolutely convinced that we'll get one come in and I'll be able to make this set back up. I mean, there was an AM version of these. I remember going to Goose Fair in it would be 19, I can't remember whether it was 81, it couldn't have been 81, no, it must have been 82. I went to Goose Fair, the world famous fair at Nottingham, and on the Hoopla stand was one of these. But it was the AM version for the American market. So there you are, you could have won an illegal CB, but I wouldn't be surprised if the same coil isn't on a useless AM set. Now, there's no We can't be breaking this, getting it out. PT40s used to be one of those. Every time I bought a batch of sets with 5 sets, every time there would be a PT40 in there of some type. I just fixed them all. I can't see a number on the Lowe. The cheapo one, $320, 2010, I211. Because I've dropped it on the floor, haven't I? So where are these made? Just wonder if there's something else. All these dreadful Lucas sets here. What have these got in them? What brand are these? SINAD. SUMIDA. SINAD. No, they're not SINAD in that. Let's look at this dreadful set. Well, these have got Tango in them. It's unbelievable. Just have a look at the final. What the Maxon put in. Elite. What about this type of... Well, these have got SINAD in. In some. Anyway, it's something to look at. I'm going to write L17 SINAD 320 2010 I211. So I don't like borrowing parts. We've done it before and then been 10 years getting them back. So was this some half-baked magazine project or what? I don't know. So 10M08AC Uniden. I mean, the fact it's Uniden branded, I wonder if they've nicked it out or something. Not a bought-in part, surely, which says Uniden on it. Right. So is C65 missing? Well, C65 is shown to be there. C65. So I reckon this bodgerie happened in 1984. Got one for a clearance $29.99. And fancied themselves making it. Oh, look, I've got no bleed over, none at all. Can't hear anybody, but it's got no bleed over. Right, we'll go to parts department, unless there's a capacitor kit over here. You know what, there's a capacitor kit over here, but I don't want to move it because it's got some current projects stacked on top of it. Okay, so we'll put a capacitor in. Put the other glasses back on. Okay, so it might have a fighting chance. I tell you what, that's a massive solder blob. Enough lead for a church roof there. So hopefully we'll put it back to standard, and before we go anywhere with the tuning, I'm going to see whether the set works better. Or worse. see where we are frequency wise, because this is now 4 hours later and things will have warmed up. So transmit is now 2779114, so we'll have our signal generator the same, 79114. It's not likely the two transmit and receive are going to be different on this, but it's a sensible place to start. So we'll go back to the SINAD meter. And we need to be better than the 3 microvolts we had before. And right off the start, we're at 1.4 microvolts. So let's just see if we can tune that coil I've put in. Wow. Okay. So by just changing that one as to how it should be, we've got 0.59 microvolts. Not touched anything else. So we'll just put in brackets 0.59 microvolts after repair. Good. Right, we'll get on with what the service manual says. Right, got all this to do, and we do start with the receiver. Connect the RF voltmeter to test point 1, adjust coil 4 for maximum. So test point 1, I'm sure some are labelled and some aren't. So once again we've got to look at where test point 1 is. You know, if you're doing these all day, you'd know where it all was. It's like resistor whatever for the VCO on the cybernets. Same with this, the unidens. Test point 1. Test point 1 is there. So it's either capacitor 68 or L4. Capacitor 68 L4, capacitor 68 I'm going to use the matrix to find that, aren't I? B2. B2. 67, 68. And it goes down to L4. So it's not got a very long lead, has it, folks? Because you know what? Is it this wire? You know what? It's that wire, isn't it? L31. It's the wire. So next we've got to find our huge Russian meter, which I probably haven't used since last time I did one of these. So select channel 1, I'll put the squelch on, there's channel 1, and we're going to be adjusting L4, which is that one, for maximum. So there we go. I've gone and put it on top of the tool. Go up a scale. Right, that's maximum. Do we put that away now? Next, connect a frequency meter to test point 1 and adjust CT2 for 10.24046. Do not retune L4. So, get this probe, put it into our frequency counter. We could use that little oscilloscope we've got. I might do that. It depends whether we get a good reading. Just temporarily solder an earth on. I can bet at the factory they do one adjustment and pass it across the conveyor belt. Let's put an earth on there. Right, let's show the frequency counter. Put it to external input because it's on the test set was on reading its own, and we put it to test point 1 where we've been. .240.237. So 10.240, we want 46. 24046. 24046. we're adjusting CT2. You see, people would just think, oh, this is the crystal trimmer, we'll set it on transmit, but you don't. And what we're adjusting, CT2. Ooh, too high. 2404. Right, I think we'll leave it there. 240459 toggling, we're just about there. Then we want a multimeter onto test point 2, and this is our VCO. We need to adjust CT1 for 2 volts. I'll leave that earth in place. Let's just see if I can find test point 2. Test point 1, we've done that one. Test point 4, test point 3, test point 2, resistor 8, capacitor 26, resistor 3 junction. So 8, 3 and 26. Yeah, 3, 8 and capacitor 26. Capacitor 25. There's resistor 3, there's capacitor 26. Don't know where the other one is, so it's going to be resistor 3 and capacitor 26. So we've got no insulation on there, so that's going to be the test point. Right, we'll get the other multimeter then, the ordinary one. Right, I'm going to borrow this earth, which we'd been using with the audio. So we're getting 1.7. And it should be 2.5, sorry, 2 volts, 2 volts. So CT2, let's find CT2. Sorry, CT1. CT2 is there, we've done that one. CT1, they're good quality trimmers these. It's there. And we want 2 volts. No matter which way I go, it's going to be the wrong way. I think we'll leave it at, oh there we are, 1.99 toggling 2. We've done that. So we've done that. So stage 4. So we want the RF meter to test point 3. And what we're adjusting, L2. So there's L1, there's L2. So junction of capacitor 63 and L2. Capacitor 63 is where? There. $43. This must be 63. Yeah. Right, we'll get the big meter back. Take away the multimeter. So all those of you can whip through a Cybernet set in 20 minutes. Now you know why all these aren't aligned. So here's the thing. Or is it the other side of it which we can't get to? Well, let's see whether we can get a reading. And L2 is that one. We've got a peak there, regardless of what it is, we've got a peak. It might be the other side of that capacitor, which I can't get the probe in on. Yeah, it's there, isn't it? Let's try that again. And it has made a difference. There we go, that's peaked. Put the big Russian meter back. Right, I think we're there. Right. So we now want the signal generation on the correct frequency. And we do the tune-up. So I'll need to put my earth back on the speaker lead. There we go. We're on channel 20 now. Right. They're just tuning it on the S meter, which is fair enough. We're going to be using the SINAD meter. So 14, wherever 14 is. 15. Let's put the right meter up, you're not seeing what I'm doing. 16. 17 we've already done, but we'll recheck. Yep. 18. 19 and 20, which is our detector. 21. So I'm going to pause at this. We'll do the detector next. Let's go over to camera 3. Bit misshapen, but not the end of the world. 21, isn't it? Like my age once was. It's down here somewhere, surely. No, it's there. That's our peak. It was right. And I will take their advice and look at the meter, because that's what we want to be doing as well. I've just gone and knocked the frequency now. I've put it right. So I'm looking at the front panel meter, the oscilloscope and the SINAD meter at the same time. We'll keep it on the oscilloscope for you. Believe it or not, that looks right. I'm now looking solely at the SINAD meter. Put a bigger signal back on. We straightened out the oscilloscope quite a lot. I'm going to recheck the detector. Just see what we've got before going any further. dB 0.59. So it was 0.59 as soon as we did that repair. So that just goes to show nothing was out of tune. .49. It's 0.98. Now we want preset 3. They actually want 1 millivolt on your signal generator for S9. Well, we do 100 microvolts, whatever the service manual says. That would be quite a def meter. We're going to adjust VR3, wherever it is. It's that one. Now, I never touched that, you see, and it was quite a bit low. and then squelch will be VR2. And what was it? It was rather weak before, but we'll see what we can do. So I'm going to put squelch to full. Show you the attenuation. We can see it between the wires and things. That's at 0. That's now quite deaf. So VR3, I want to adjust. Sorry, that was VR2. VR2, it's that one. So we've now got the squelch opening, it's 100 microvolts for full. So let's see where the sensitivity is on the squelch now. Set the squelch. Signal generator is on standby. It's parked at 0.3 of a microvolt. We'll switch it back on. Oh, that's atrocious. What was it before? It's worse than it was before. Let's give it another go. $100 microvolts, set that. Put that back to standby, turn the squelch down on the radio. Switch the signal generator back on. It's 1 microvolt. I'll go and have my tea. Right folks, time to get to the transmitter. Will we get more than 3.1 watts? Are we that bothered? 5, 6, 11 and 12. 5, 6. Where's 8 come into it? Oh, it's 8 for the power set. Five, 6, 11 and 12. Alright, here we go. So we're on channel 20. It's doing 3.1 watts as we discovered before. 5. Was correctly at peak already. So was 6. That one's heating up. If you think this is taking ages, only just put the soldering iron on. That's it. That was already at peak. That one's heating. Hey, 3.2. And then set the power with L5. L8, sorry. Check placement of that coil. Tell you what, we're whisk away from 4 watts. I would think when that's cooled down it's 4 watts. So we'll come back to that. We want the meter to read something sensible. They want it to correspond to the 9 mark on the meter. There's a little dot past the 9. So although we're looking at the receive scale rather than the power scale, that's where they want it to be. So we'll key it up again. It's just slightly fast of that now. So VR1. Of course, there is a psychological thing that people who think that if the meter reads 1, they're only doing tiny power, and if it bangs across, they're doing big power, and of course it doesn't mean anything like that. VR1 is the one at the back. It's a bit dirty, that one. It's the first one of those we've had to fiddle with. There we are. I think we can unsolder that test probe. I'm going to do the deviation next, whatever they say in the book. Let's plug this into the test gear. Wow, it's 2 exactly, so it needs to just pop up a bit. Deviation VR4. Where's VR4? I'm expecting it to be somewhere around there. That's not, that's 4. There we go. Wallow. Wallow. That's it. Let's go back to the other test set. I'd be interested to see what this test set says. Wow, it says 2, so it's reading low today. Right, so that's that done. We've done RF meter, we've done the S meter. The potentiometers have, once I've started moving them, they've been okay. Deviation was 1.8 to 2, which was okay, but it's now 2.2 to 2.5. Right. So low power VR10. Switch to low power. VR10 is there. It's 350 milliwatts, so it's pretty close to where it should have been. That's it. But it wasn't, you see. Well, now I've done the read to, and it sorted itself out. Go to high power. We'll do the current consumption now. 1.13. 1.13. So we've only gone up 100 milliamps to get virtually an extra watt out of it. I think we're about 3.9. It's frequency next. I'll keep it on low power so we're not heating up the transmitter. So VR9 is the transmit frequency. So all that thing with all the test points and that was setting the receive. It's actually the delta tuning setting. So transmit is this preset. It's bob on 4 watts, by the way. I'll just go back to low power. Show the frequency counter. 277912. Five. There we are. Right, so I've seen 4 watts now. Let's go back to the main meter. It could do with cooling down a bit more for a true reading. It might be a little bit over. I'm sure the DTI aren't going to come out. So 4 watts is there, and we're on 4 watts. I'm not showing you the right meter. 4 watts is there, and we're bang on 4 watts. Channel 40, 3.95. Channel 1, 3.95. So don't often see power up here with these. Usually around about 3.6. I mean 3.1 would have been fine. Right, we've done that. I just want to recheck the squelch before I call it a day with it, but I'll do that in about an hour because I've got other things to do. So that's the alignment. What's it supposed to do? Does it tell us? Sensitivity, typical 0.2 microvolts for 12 decibel SINAD. I don't think I've seen that on one. But that said, it depends how you have the test set up. I've borrowed the earth, haven't I, again? Right, so that 12 dB, let's go back to SINAD meter. So there's our 12 dB, which at the moment is 0.59, as we've got on the clipboard. But we are in EMF mode on the test set. If we put it into the easier to achieve PD mode, we've gone beyond 20 dB. Let's see what we are now for 12. The answer is 0.24. So they don't stipulate which mode they want you to be reading this in. We always use the harder one. Of course, manufacturers are going to quote the easier one, aren't they? Nothing changes. Right, so that's it. We'll just I just want to make sure the squelch is absolutely as good as it gets, and then we'll call it a day. Okay, so squelch is the biggest letdown on this. It's 1.2 microvolts. Just check that we're... I'll just put that to full. Yep, everything's set up right. 100 microvolts. So there's your letdown. There's always going to be one, isn't there? Right, we'll put that back together and put it on an aerial. I think we'll run with the standard replacement mic. Should have done that on yesterday's Uniden base station. We used the nasty bassy mic which they come with. and not everybody necessarily watches the end where we go through to the base station and try other mics. So it's cost me nicking a part out of one of my own sets, hasn't it? So we've got to hope that one comes back. Nobody would have paid 70 quid for this or whatever they were new and done that silliness to it and then just put it back in the box. I mean, they could have reversed the silliness, couldn't they? I perhaps thought it was brilliant. Yet. Right, aerial. As I always say, it's the Solarcon 99. 6 feet from, not a lot more than 6 feet from the ground. Just put an mic in. One and a Roger. Nothing different there, is there? 6 o'clock. They're all having their tea. And there we have it, the Lowe TX40. I was astonished what has been done to that. I just can't believe people do things like that. And you know, how can anybody think they've improved it and not reverse it to what it was before, when they discover it's receiving at 3 microvolts instead of, well, we've got the 0.59. Thanks for watching the Lowe TX40 Immaculate box set from 1981.